Today we are discussing about the chapter chemical kinetics from physical chemistry. Chemical kinetics. This is the most important chapter in 5th semester final degree students. Listen carefully. So, here chemical kinetics. Chemical kinetics is nothing but it deals with the rates of reaction. It deals with rates of reaction. So rate is nothing but speed. Have you understand? Rate is nothing but speed. So what is rate of reaction? So what is rate of reaction? Rate of reaction depends upon one mechanism of rate of reaction, and second one factors influencing rate of reaction. So rate of reaction depends upon mechanism of rate of reaction, factors influencing rate of reaction. See, we can discuss about mechanism of reaction. Okay, note down this one. See, mechanism of rate of reaction. So, mechanism of rate of reaction. First, we have to know the definition of rate of reaction. So, here, rate of reaction is nothing but the change in molar concentration. The change in molar concentration of reactants or products per unit time. The change in molar concentration of reactants or products per unit time. Okay, this will have a small equation. So where R is rate of reaction, we can write so dP by dC by dt for instantaneous reactions. So where dC is the change in concentration, where dt is the time interval. So dC is change in concentration. So delta D is the time interval. Okay, have you understand? We can write in another way. So rate of reaction is nothing but the decrease in molar concentration of reactants or increase in molar concentration of products per unit time. Okay, that also we can write some mathematical expression. Okay, here we can write the another form, the decrease in molar concentration of reactants the decrease in molar concentration of reactants or increase in molar concentration of products per unit time. Okay, we know that. So where R is equal to delta C by delta T. So delta C is the change in concentration of products or reactants, where delta T is the time interval. So with respect to reactants, we can write the mathematical expression. So where R is equal to delta C by delta T. So here we have to put negative value. Why? Because the decrease in molar concentration of reactants. So with respect to product side, where R is equal to, if there is a negative value, here increase, so we have to put positive value. So delta C by delta T. So here are the equations. Note down, these are very important equations of this chapter. So we listen that rate of reaction and their mathematical expressions. So if we provide a graph for them with respect to products and reactants, with respect to products or reactants. So here is the graph I am writing. So first reactant side. So with respect to reactants, we are writing. So R is equal to minus delta C by delta T. So here there is a decrease. So we can show that the decrease of reactants like this. Here is the graph for reactants. So this is the time interval. So this is the decrease in reactants. Is the decrease in reactants. We can assume the graph like this. So the graph decreases from up to down. So with respect to the concentration of reactants is decreasing. So similarly, we can write the graph of with respect to products, where R is equal to delta C by delta T. So this is the graph. So this is the increase in product side. This is the time T. This will increase like this. So here are the graphs, just illustrating you. Okay. See. So rate of reaction, we know that. So increase in reactants, decrease in reactants or increase in products. So we know that R is equal to delta C by delta T. So it is the rate of reaction. Units for units are, listen carefully. So moles by liter into 1 by T, where T is equal to, we can write seconds, minutes, hours. Okay. See, we can write seconds, minutes, hours with respect to the times. So we can write like this: mole, liter inverse, time inverse. So here are the units for rate of reaction. This is the most important one. Write down it. Okay. Next, for stoichiometric, rate of reaction having general formula. So that is we know that rate equation, nothing but rate equation. So it is the general one: XA plus YB plus gives rise to XA YB. So MC plus small and d is the stoichiometric general formula. I will illustrate an example. I will illustrate you an example. So we take 5Br plus BrO3 plus 6H plus gives rise to 3Br2 plus 3H2O. This is the equation. Okay. So general formula is, so X means this is the molar concentration coefficient of reactant concentration. A means reactant concentration. X is the coefficient of A. Y is the coefficient of B. Here M is the coefficient of C. N is the coefficient of D. We can write this equation like this. So 1 by X. So here coefficients will come to the denominator. Okay, with respect to reactant side or product side. So rate of reaction expression is like this: 1A by X. So this is the reactant A, reactant B. So reactants always in decrease in molar concentrations. Okay, so we have to put negative value. So dA by dt is equal to, so again this is also reactant, minus 1 by y. So B we have to write by delta T is equal to, so M is the coefficient of molar concentration of product. So product means, so always increase. If there is a decrease in reactants, there is an increase in products. So 1 by M delta C by delta T is equal to 1 by M delta D by delta T. So here is the equation for this general equation. So like this, we have to write 5BrO3 plus 6H plus gives rise to 3Br2 plus 3H2O. Okay, so I am writing like this. So see, so 5 is the coefficient of bromine, so we can write 1 by 5. So this is also reactant side, we have to put negative value. So again, there is no coefficient, so we have to assume 1 is there. Okay, so 1 by 1, this is negative value, so this is also reactant. So 6H plus, this is also reactant side, so minus 1 by 6 plus by delta T. Similarly, product side 1 by 3 Vr2 is equal to 1 by 3 H2O delta T. Here is the equation. Note down. We know that rate of reaction for large reactions, we know that delta C by delta T. Okay. For instantaneous reaction, we write R is equal to dC by dt. That is the derivative of concentration of reactants or products. So this is the derivative of time interval T. So delta is another one and D is another one. So this is varied from. So this is known as derivative. So this is for large reactions. This is for instantaneous reactions. Okay. So here, so mechanism have completed. So next one, factors influencing rate of reaction. So factors influencing rate of reaction. So there are many factors are there in rate of reaction which influence the rate of reaction. That means they will increase the rate of reaction, they decrease the rate of reaction. How the rate of reaction is done? Okay. So first one, concentration of reactants. We already discussed the rate of reaction. In this term, concentration is there. So what do we know the concentration? So concentration. So rate of reaction is always proportional to concentration. Is always proportional to concentration. Why? Because if there is decrease in reactants, so there will be increase in product side per unit time. That's why, so rate of reaction always proportional to the concentration. Okay, this is the molar concentration for n terms. So we can write rate of reaction is equal to K into C power n. So K is the probability constant. K is the probability constant. Okay. So this is the concentration of reactants. Another one. So another one, effect of temperature. So effect of temperature. So if temperature, when the A plus B uses to products. So there is a reaction between A and B. If temperature would act on the reactant side, there will be increase in the rate of reaction. So hence the product will consume. So if we apply 10 degrees, if we apply 10 degrees Celsius temperature, the rate of reaction would be double. If we increase 20 degrees Celsius, the rate of reaction would be triple. So when the temperature is, when we increase in the temperature, the rate of reaction also increase with along the temperature. Okay. So see example here. If we increase 10 degrees centigrade, the rate of reaction would be double. If we increase 10 degrees Celsius, So rate of reaction is doubled. So we can write, so rate of reaction increase with increase in temperature. So note down this one, very important one. Okay. Next one, effect of catalyst. Next one. So next one, effect of catalyst. So we know that what catalyst do in the reaction. Catalyst doesn't involve the rate of reaction, but increase the speed of reaction. That is the catalyst nature. So catalyst we can write which alters the rate of reaction, which alters the rate of reaction without itself used in the reaction. Okay, without itself used in the reaction. So it doesn't involve the reaction, but it increases the rate of reaction. So I will assume with a graph. See, so this is the Hg. So reaction of catalyst reactions of catalyst coefficients. So see, with catalyst the rate of reaction will be like this. Without catalyst the rate of reaction would be like this. So this is without catalyst. So this is with catalyst. Okay, I have observed this graph. So when the catalyst is there, the rate of reaction speed increases. So then the product will come soon, as very fast. So without catalyst, see the graph. So there will be huge difference. So there is the huge difference. So between with catalyst or without catalyst. Okay. So next one, effect of pressure. Effect of pressure. So effect of pressure involves in solids, liquids and gases. So more importantly, pressure is always occurring. We know that in gases. So when the pressure increases, the rate of reaction also changes. It may be affected. So I will illustrate an example. See, first one. So N2 plus 3H2 gives rise to 2 NH2. So these are all in gaseous state. See here, when we apply pressure or when we increase the pressure, here in case 1, so there are how many molecules are there? 3 plus 1, 4 molecules are there. There is the decrease in molecules. Here 4 molecules, here only 2 molecules. In case 1, when the pressure is involving, in one case 4 molecules convert into 2 molecules. So there is a decrease in number of molecules with increase in the pressure. In case 2, second example. N2O4. This is also gas. Gives rise to 2NO2. Here you can see that. So N2O4 is one molecule. Here NO2, there are two molecules. See here, when we increase the pressure, so here there is increase in number of molecules due to the envolving pressure. So pressure may alternate or affects the rate of reactions. Okay. So in case 1, there is decrease in number of molecules with increase in pressure. In case 2, there is increase in number of molecules with increase in pressure. Okay. Write down. So next factor is effect of solvent. So solvent is used in very large excess. So it doesn't involve the reaction, but it is used in large excess. Why? Because so solvent is always acts as space filter. Okay. So effect of solvent. So we are discussing. So it is used in large excess amount in the reaction, but it doesn't involve the reaction or increase the reaction. Just act as a space filter only. So we can illustrate with an example. So I am writing down. You also write down the notes. So C2H5. So this is ℕ𝕚𝕚𝕚 plus so methyl iodide. Okay, gives rise to at 373 degrees Kelvin. We apply solvent. What it will give? So 3, 1. So total tetra. C2H5 4 iodide. This will be what? This will be D2. Here is the equation. So C2H5 thrice N. So iodine C2H5. In the temperature we are applying 373 degrees Kelvin. So with solvent, it is used in large excess. So here is the equation comes tetra methyl amine iodide. So solvent doesn't participate in the reaction, but it acts as the space filter. Okay. So solvent always acts as the space filter. So that's why we use large excess amount of solvent in the reaction. Okay. Next. See the next topic. Effect of nature of reactants. Effect of nature of reactants. We already discussed the concentration of reactants. So rate of reaction depends upon concentration of molar concentration of reactants or products. We know that. Here we are writing the effect of nature of reactants. In that the concentration of reactants, we are writing that. So effect of nature of reactant is divided into 3 types. So first one, ionic molecules. So covalent molecules. So this one we discuss later.
Moderate molecules.
Here ionic molecules. In the ionic molecules, the rate of reaction is fast. Rate of reaction is fast. In the covalent molecules, the rate of reaction is slow. So why in the ionic molecules rate of reaction is fast? why in covalent molecules rate of reaction is slow? So once listen. So why? Because in the ionic molecules rate of reaction is fast. There is no making and breaking bonds involved in the rate of reaction in ionic molecules. That's why the rate of reaction is very fast. In these covalent molecules, rate of reaction is slow. Why? Because there is making bonds or breaking bonds involved in the reaction. So see here example, NaCl. We know that NaCl is sodium chloride plus H2O gives rise to NaCl aqueous instantaneously. So when we mix with water, salt becomes aqueous salt. So it is very fast in the rate of reaction. If we take another example for covalent molecules, N2 plus O2 gives rise to 2NO2. This is slow. Why? Because there are many bonds occurring in this equation. So we can write like this. N2 means N triple bond N. So O, we can balance the equation. So N2 plus 2O2 plus 2 O double bond O. Okay. Here gives rise to 2 N double bond O. So this is covalent bond O. So NO2 is a covalent molecules. Here there are many bonds occurring in this. So see 3, 2. So 3, 2 into 2, 4. So again 2 into 3, 6. There are nearly 13 bonds involving in this equation. So that's why the rate of reaction is slow, because here there is making bonds and breaking bonds involving in the reaction. That's why covalent molecules rate of reaction is slow. Here there are no breaking and making bonds in this. That's why the ionic molecules rate of reaction is fast. Okay, have you understand?
After ionic molecules and covalent molecules, there is another one later I say, that is moderate molecules. Moderate molecules takes time very long. That's why they are very slow. Example, rusting of iron. Here you can see in the picture how the reaction of rusting of iron is takes place. Okay, and
next one. So next factor, effect of surface area. So see, effect of surface area is also a factor of rate of reaction. So why? Because once listen, I will illustrate a small example. You can listen carefully. So if you take powdered sugar, lump sugar. So when we mix powdered sugar in water, it will easily dissolve in it. As quickly in seconds or minutes. If you take lump sugar, it take more time. We can mix the lump sugar in water. So there is the difference. Powdered sugar is more quickly dissolved in water as compared to the lump sugar. So that's why surface area is also important factor of rate of reaction. So when we take water, so this is the powdered sugar, this is lump sugar. So lump sugars are in a cubic crystal type. So powdered sugar is, we know that. So powdered sugar, when we mix powdered sugar in water, so it will easily dissolve. So completely in seconds. If we take lump sugar, it would take some time to dissolve in it. So surface area is also important factor
Okay, here you can see in the picture, solid is splitting into several pieces. See the lower surface area and higher surface area. The small pieces having the large surface area, so this having more collisions and great chance of reaction. So higher surface area easily dissolving water. Okay, next topic is effect
Radiation. So radiation is nothing but heat energy. It will occur from the UV lights or sunlight. Okay. So what is effect of radiation? So there is increasing absorption of photons in the rate of reaction. The absorption of photons would increase the rate of reaction with the heat energy of the radiation. Okay, radiation is nothing but absorption of photons. Okay, listen carefully. So these type of reactions are photochemical reactions. So if we take example H2 plus Cl2 under H nu. So H into nu is equal to H is the Planck's constant, nu is the wave frequency. So if the product gives to is equal to the sunlight. Okay. So H2Cl2 under the sunlight, it will give 2 HCl. So these type of reactions are known as photochemical reaction. Photochemical reactions. That means the reactions are participated in the presence of sunlight. Such type of reactions are known as photochemical reactions. So this is involving in the factor of influencing rate of reaction. So effect of radiation is nothing but the absorption of photons in the reaction gives the product as early as possible. So such type of reactions is known as photochemical reaction. So today's lecture is over. So wait for the next lecture. Signing off.